I wanted to do this just because I've been helping a number of people with some of this AI stuff over the last few weeks. And I'm conscious that probably it was a little bit haphazard. It might be useful to pull this course together, which kind of takes us back to first principles and then kind of builds up as we go. Hopefully at the end of this, we'll have essentially what I see as a useful agent, something that can help you with either your business or even just help you with your personal life, and uses the full power of AI and all those capabilities, and we'll kind of build up towards that. So that's kind of the intention of what I'm trying to do. So I've spent quite some time trying to pull this together, and hopefully it works. Today's session is a little bit about what's happening under the hood. The reason why I wanted to do this session is because almost if you really understand what's happening under the hood, actually when you're using it more actively, you use it in a slightly different way. This is not going to be lots of mathematical details about how machine learning works under the hood. And then I think I'm going to try and make it a little bit practical as well in today's session, but from next week, it's going to get very practical and we're going to actually start, some real building. So this is today's agenda. And we're going to kick off a little bit with a live demo of what I call a weekly digest. And it's a week where you kind of capture what you're doing during that week. And I thought this weekly digest would be a great example because, well, everybody has a week and everybody has a lot of different stuff that they do during that week. I'm just going to come back here to this week of noise. So this is something that all of you can do, capture what's happening during the course of your week. And we're going to try and use this example to build up through the course of these 8 weeks that we're working on. So that at the end, when you have your week, this agent can help you manage essentially your business or your life or whatever you want to do. So the first thing that we can do is we can take this week and we can put it into Claude. And what I did was I took this exact week of noise, I put it into Claude or ChatGPT or Gemini. I tend to use Claude because I think it's certainly the best LLM, which I've found. I mean, ChatGPT is also, I would say, a close second. I tend to use Claude for most of my stuff. So I took this content and I pasted it into Claude and I said, I have detail from our past week. Please, can you help provide a weekly digest to analyze it? Which it did. So it came up here with this weekly digest and sort of came up with this, what are the wins and the progress? Your Kettering proposal was submitted, your Q2 briefing published, Ollie's Fenwick mapping signed off, open actions. It had some parked ideas. So it really kind of took that and it created, I think, a fairly nice summary of what that week is and some things next week, key moments for next week. So a good week overall. Standout was Kettering proposals, submitted on time despite midweek scope change. Few things worth calling out. So it was okay. It was an okay digest because these models are pretty good. But I think the one thing that it really missed was it wasn't particularly specific. And so the other thing that we're going to learn is that we really need to understand about context and how context really improves what happens. What I've got here is a persona page. Again, this is this fictional person, Alex Okafor. And in this particular case, I've put in some specific information. So who Alex is, his current priorities, what's important to him for this in this particular moment. Also put in his working style and preferences, direct communicator, bullet points to pros, skeptical AI hype, hates vague advice, explicit values, client work comes first, shipping greater than perfecting, reputation matters, and what he wants from a weekly digest, where time actually went where it's supposed to go, which priorities move forward, concrete recommendations, specific flagged risks, and noise filtered out. If you can just do one simple thing to kind of create that additional context, what does that do to the weekly digest? What I did was I then said, I should have given you a bit more context. I've now attached the persona document. Can you regenerate? And now what happens is when you give that specific information, suddenly it becomes a lot more specific. So just a little bit of that additional context means it said that he wants to know about priorities. So clearly this priority track trying to do that. It said that he needs to know what is slipping. So these are the 3 things that need to be chased. It said, he needs to know where his time actually went, where it was supposed to go, where it actually went versus where it was planned, and then filter out the noise. I think the key thing here is making sure that you can give it that additional context which I think is very important. And that's going to be a key thing that we're going to be focusing on. That digest is something that we're actually going to be working on over the course of the next few weeks, and we're going to build up on that to the point where you're going to have something that's got memory capabilities that these new AI models have. Okay, so the first thing that pick on is weekly digest, and what we saw was without context, it was kind of very generic, but with the context had a lot of specificity to it. The first thing that we've got to understand is like, so how does this process actually happen? Taking everything in this, it's kind of zipping it up into models. And the way to think about it is a kind of a 3-stage process that's going on here. In the first stage, it's kind of what's called the pre-training stage, is all of this information is really being trained into these large language models. It kind of has a rough idea. And what it's doing is it's really getting the patterns of what's happening across all of this text, and it's putting into these model parameters. That's why it sometimes gets to specifics, because really there's a lot of compression that's happening as it's going through this training process, and it's these patterns that is the thing that it really records. So when you use specific words, it's kind of knows which other words to associate with that. And it's these patterns that is getting through, not actually explicit facts that are being recalled. So the way to think about the model is it's kind of a compressed form of the internet, a very lossy form, and that's why you've got to be very careful that it's not actually these specific facts that it can remember. And so it knows roughly everything. It's got a broad knowledge, but not specifics. And so these model parameters, what are these model parameters? It's doing its training. It's actually just picking up tokens, not words. And I'm not sure if you understand what tokens are, but essentially what's happening is all the text that was picked up on the internet is all broken up into specific words. And in fact, it's not even individual words. If I come here to a specific website called Tokenizer, this actually is a website that shows you how text is broken up into tokens. So if I simply type in here, if you do the cat sat on the mat, that gives you one word equals one token. But if you take a word which is not as common, then of course it's going to be broken up into smaller tokens. So I think my example here was electroencephalography. Yeah, so in that particular case, broken that up into these particular tokens here. That's quite important because it doesn't understand a word. It understands these tokens. The reason why it's broken it up into these tokens is because essentially what's done is it's taken a text which it consumed. It's then worked out an optimal number of common words or grouping of letters that appear most frequently, and it's then said, okay, this is the most optimal way of breaking up this wall of text into something that I can actually digest. For example, it's not surprising that in this particular word, ography is its own token, because of course that would appear quite commonly under other words which are quite complex and end in ography. So that's like a common token. So it understands that as being a token. It doesn't understand the actual words themselves. And that's really, really important. And that's why you've kind of heard these stories where it can't calculate the right number of letters in a word, for example. Common one was how many R's are there in strawberry, which many models got wrong for a long period of time. And that's because it doesn't understand the concept of the word and the actual letters within the word. All it understands is these tokens. And I think that's really, really important to understand because it doesn't think in the way you and I do in terms of those words. And that's also important because that's where you need to understand how the model gets some of these things wrong. And you'll see later on when we talk a little bit about hallucinations, you'll see that this is kind of one of the key reasons why some of those hallucinations happen. The other thing is also, I mentioned that it knows these patterns, and that's all its understanding is those patterns. So another one that it often gets wrong is in calculations, arithmetic. If you tell her what is 2 times 2, it doesn't actually understand that arithmetic. Of course, it would get 2 times 2 correct because in the training data, it would have seen that many, many times because that would have appeared in many, many websites and much of its training data. So it knows the answer is 4, but it knows that because it knows the pattern. It does not know that 2 times 2 is 4. And there are strategies that you can use to help overcome that by giving it certain tools that make sure that those things work a lot better. Yeah, so it comes down to these model parameters. And so you would have heard that these large language models have 175 billion parameters. That's how these patterns are recognized, is through these model parameters. So the next thing is I want us to try and understand a little bit about what are those model parameters? How do they come about? Yeah, so we talked about the tokens as words, and common words are one token, unusual words split into parts. That's why it does these misspell or invents letters. It can't really reliable count characters, can't do exact arithmetic. And there are some tools we'll see when we talk about hallucinations, how to avoid it doing that, is to use tools or to use extended thinking or to ask it to write code for calculations. The next thing we need to understand is, what are these parameters that we're talking about? The way in which I want you to think about it is, when this training happens, words or tokens become what's called vectors. And these vectors are essentially a way you've got to think about these words as being in this multi-dimensional space. And so, for example, the word king will get a numeric representation, and that numeric representation will be a series of numbers. So if I look at this website, the word king will, in the model, be given not just one number representation. It'll be given an entire vector of numbers. And the way to think about it is, these individual numbers basically show how the word king relates to other words or tokens in the wall of text that it got trained on. So for example, the word king would also be associated or be similar to the word prince, for example, and would also be similar to the word queen. And so in that number representation, the way to think about it is, like, I can think about a dimension of that word which is aligned to royalty, right? Because those similar words would be almost in that royalty dimension. And the other thing is the word king. If you think about another word, let's say I take the word man, and the word man could also be associated with king because king is a male. But equally, a man would also be associated with other words, like woman. Okay, and so you can think about man and woman. There's a type of a vector or a numerical representation which is associated with the concept of gender. And so each of these numerical representations is associated with kind of a semantic meaning, and words are linked together or are closely associated together with some of these semantic meanings. And in fact, these numerical representations can actually be calculated because it's a numerical representation. So if you take the numerical representation of king and subtract man and add woman, you'll end up, roughly speaking, with something very closely associated with the numerical representation of the word queen. And that numerical representation is a way of thinking about how all of these words that it's been trained on have been given this numerical representation. And as it's been doing its training, it's learning to put a certain numerical representation with various types of concepts like gender, like royalty. They kind of work, and the numerical representations show that they work. But in reality, the model is just looking at that text and saying, when do I see the word queen? I often see it associated with king, and I often associated with man, and the numerical representations kind of just come out of the model. And that's why, if you think about this huge, enormous like set of dimensions, and the words kind of cluster together, and that's how these patterns actually emerge, so that when the model is predicting the next word, it will often use that semantic meaning to pull out words that are associated closely with that. So that's the way in which to kind of take those tokens, which we talked about, and how those tokens can either be typically words, but often portions of words. And when the model is finally trained, it's got all of these numerical representations which form these patterns. And that's how, when it goes in, it's going to pull out words that are closely resembling or associated with those words based on that numerical representation. The same type of things will happen with, for example, I could use another example where Paris minus France plus Italy equals Rome. So exactly the same type of thing will happen, where it will associate capitals and countries, and those words will typically be close together as the model trains. And that's how it makes those associations in this kind of multi-dimensional space once the whole model is trained. I want you to make sure that you understand that it doesn't know these words. Okay, it knows a numerical representation, and as it's doing the training puts these words close together in this multi-dimensional space, so that when you call the model, it's really pulling those tokens which are closely represented, and which is the most likely token which is going to appear next in the set of words that you're using. So that's just, again, a little bit more context and background on how the model is actually working under the hood. The context window, this is probably one of the most important things that we're going to be dealing with. So when we're talking about the parameters in the model and the internet as a zip file, it's calling on all of those patterns to kind of predict the next word. And that is what the model is calling on. One very important thing is that actually you can inject something into the model to make sure that it picks up the right words and the right patterns much more cleverly. And we saw that earlier on my digest example. So on the digest example, when we first put in the generic digest, it didn't have a lot of very specific context. It used that pattern matching to pull up a reasonable digest. It looked pretty good, had the right sort of things. And that's because it used its pattern recognition to understand, well, what is a digest? What are the type of things that were in that week? And it could pretty good crack at doing that. But when we actually added the additional context of that persona, it got a lot more specific. And that's because what we did was we put that persona information into the context window. And what the context window is doing is it's basically taking that additional information and it's feeding that into the model. And what that's doing is it's almost lighting up a different set of parameters. And that specific set of parameters means it can get a lot more specific about how to answer that question. And so the way to think about it is the internet information is just these patterns, whereas the actual context window is the working memory of the model. And you can put, in this particular case, we've got the Alex persona, we put in the week of noise, it's pulled in the various priorities, and that very specific information allows it to pull up a much better set of patterns and answer the information much more specifically. The problem is that obviously eventually this information falls out of the context window, because the context window is only of a limited size. We talked about tokens, and the typical context window is somewhere between 250,000 and 1 million tokens. But even with a 1 million token context window, as you put more stuff in there, it does start degrading. The quality of the responses does start degrading if you put too much in the context window. So reliably, I would say probably between 250 and 350,000 tokens is a reliable size context window to really get good quality information out of the model. Through the remainder of these series, a lot of what we're going to be doing is we're going to be talking about how to manage this context window really, really effectively, because making sure you're putting the right stuff into the context window, you're clearing the stuff that is no longer needed in the context window out, these models perform much better. And as a result, that pattern matching, which is happening, is significantly better. And so we're going to spend a lot of time on this context, or context engineering, as people call it, making sure that your context window has the right information at the right time to be able to answer your questions very, very reliably. The way to think about it is a desk, if your desk is very, very cluttered, if you've got a cluttered desk, it can get very, very confusing to find the right information. If you've got a curated desk and you're putting the right information into that context window and you've got a very clean desk, actually it's a much better way of getting a good result. And so you're getting a much better, more accurate and actionable output out of the model. If you remember one thing from today, it's really this context window is the critical thing that we need to manage to make sure that we get good results from the models.
Okay.
Good. Liesl, you also had a question.
Just a quick one. So because the context window is so small, would you say it's then better having, because I want to do this in work, use this for work, and I want to use it privately or for my personal, is it better to have two agents then because of the context window, or is it okay? Is that context window big enough to kind of manage them both?
Different people do different things. Some people like to have a set of context information, which is their personal persona, and then they would have a separate work persona. You can load the work persona when you're doing work stuff, and you can load the personal persona when you're doing personal stuff. You're going to get very specific answers in that particular case. Other people have a combined persona, and then you can have this thing called progressive disclosure. That is where the model will load only a limited amount of information initially. That information is enough to tell the model that something exists. So in this particular case, you might say, you tell it that I've got a work persona and I've got a personal persona, and my work persona information sits here in these files, and my personal persona information sits in these files. And that's all you tell it. And then what you do is you start working and you start doing something which is in a work context, and the model knows, because you've loaded in the fact that you've got two personas and you're asking something specific about work, it will then say, and I know the work stuff is stored here. It will then go and load the relevant work files at that particular point in time. When it's got something very specific to work, it will load the additional information it needs at that point. And that idea of progressive disclosure is exactly this concept of context engineering that we're talking about. We'll get onto that as we kind of build our agent, because we'll start using progressive disclosure in one of the later sessions. The next thing I want to talk about is this idea of temperature and randomness. We talked about the idea that when it's looking for the next word or the next sentence that's coming in from the large language model, it's not always predictable. Okay, what it's doing is it's looking at what is the most likely next word to be used. And if you are asking, let's say, what is the capital of France, the next likely word can be very highly clustered around the word Paris. And it's very unlikely that it will give you an answer different to that. If you are, for example, saying, write a noir detective story, the next likely word can come from a number of different places. And it's trying to select from the patterns that it's been trained on. And the important thing here is that actually the models themselves, you can actually change whether it's more random or more creative or whether it's more predictable. And when you're using a chatbot, typical chatbot that you go to on Claude or ChatGPT, that's hidden from you. This is kind of more on the sophisticated end. So if, for example, I go to the workbench for Claude console instead of normal Claude.ai, and if I click on the model here, so I clicked on the Claude Haiku model, I can change the temperature. At the moment, the temperature is set to 0. Right, an opening sentence for a detective story. So I've got the temperature at 0, so this is going to be very predictable. So if I run that, today walked to my office, trouble in a silk dress, I knew right there in my day, hell, probably my whole life was about to get a lot worse. Okay, so if I run that again, yep, it's giving me pretty much the same one. Run that again, yep, pretty much the same one. Okay, let me, instead of having a temperature of 0, let me change that to a temperature of 1. Let me run that again.
What's the maximum temperature, Gav? You can.
I'm not sure that what it goes up to, but I think if you take it up to like a 2, then flattens out quite a bit. I think somewhere between 0 and 2, yeah, would work. You can see, yeah, so now it's starting to give me quite a different set of lines. Okay, so you can see by changing the temperature, it's being a lot more creative. So you can see there how the temperature can make a difference. And I think this is important, especially if you're using in certain industries where you need to be more creative. The ability to tune the model to add that extra creativity can be quite important. But still, nonetheless, if you ask a question like, what's the capital of France? Even if I had the temperature turned up, the clustering of most likely answers is going to be so highly clustered around Paris. Even if you turn up the creativity as much as possible, it's still going to give you the answer Paris. And that's not because it knows the answer is Paris. It's because the clustering is of the next likely token is so high around Paris that it's going to choose that one first time every time. Going back to the idea that it doesn't understand words, it doesn't understand facts, it just understands what is the very next token that it's going to select. I want to come back to this idea of the training that we talked about. So when I talked about the internet as a zip file, I talked very much about this first phase here, which is really about the pre-training, where it basically turns the internet text into tokens. It takes those tokens and it runs it through its model in its pre-training, learning all these patterns. And what it comes out with at the end is what's known as a base model. And this base model actually is not particularly useful because the base model just knows these patterns. So if you put in some text, it's going to predict some sort of text which it learned on the internet. And oftentimes that's not very practical. There's a whole phase that happens after this training. And this pre-training is the very expensive part. This is the thing that takes months and months and months of training these large language models. The next stage is much quicker, but arguably much more important. And that's the kind of post-training. And this is where it becomes a lot more useful. And the way I like to think about it is almost like a textbook analogy. You get a textbook, there's 3 types of information that is in the textbook. There's the raw information in the text when you're kind of learning all the facts and it's getting you all the information. Once it's done that, you'll often see worked examples. And these worked examples are very important because it shows how to apply that knowledge in some useful context. And in this particular case, for these large language models, the useful context is a chatbot. And so how does the chatbot come about from this base model? Believe it or not, a lot of this is actually done by humans. What it's doing is the humans are giving it worked examples. And it's basically saying, if you ask me the following question, this is the ideal answer. And so it feeds in questions and ideal answers, questions and ideal answers. You give the model a whole bunch of these question, answer, question, answer, question, answer. What ends up happening is the model learns the pattern. eventually, after it's been given a lot of these examples, you then ask it a question. It then says, hey, I know that pattern. And that pattern is, if it asks me a question like this, I give it an answer like this. It's not as though it's learnt it from that very specific example. It's learnt that question answer pattern. And that's how a chatbot actually comes about. It's learnt the pattern of somebody asks a question, and roughly speaking, this is what an ideal answer looks like, the pattern of that answer. And what it does is it uses its internet knowledge to pull on the actual information that it puts in it, predict the next token, but it's using the pattern of that question, answer, to give you a way in which when you ask a chatbot a question and it gives you an answer, it's learned that pattern. And so that comes about through this post-training phase, which is this reinforcement learning with human feedback. And that's basically how a base model, which just can regurgitate internet information, turns into a useful chatbot that, if you ask it a question, will give you an answer in kind of the style to which you're accustomed to receiving an answer. So that's almost these kind of worked examples way in which these models are trained. The third way is a more recent phenomenon, probably in the last, I would say, year, and that is this idea of practice problems. And so again, if you've got a textbook, you often have this idea of these practice problems where it gives you a whole bunch of questions, but it doesn't give you the worked solution. It says, go to the back of the textbook and there's a list of answers, but it doesn't tell you how to get to those answers. What the textbook is doing is it's saying, well, I've given you the facts. I've also given you some worked examples. I now want you to go away in your own time and use the way in which we did these worked examples to try and figure out if you can get to the same solution that I put in the back of the textbook. And you work through those until eventually you get to the right solution. And in fact, these models are doing exactly the same thing. This is one of the biggest leaps that these models have had more recently, because what happens is during the training process, they give it a whole bunch of problems and they give it a whole bunch of solutions, and they say, go, you've already got all this internet knowledge. You've already got examples of how to do worked examples. Now go away and figure out ways of getting to the solution. And these models are incredibly good at just in the background going through multiple loops of just trying and iterating lots of different strategies until eventually they come out at the right answer. And again, that's part of the training that goes on. So eventually it learns how to do this. And that's why these newer models now have got this extended thinking or extended reasoning mode, which if you've got a really tough problem, you've got to turn on that extended thinking, because what it's doing in the background is it's iterating through many, many examples. And in fact, it might come to the same answer, let's say 5 different ways. And what it is then doing is then looking and saying, and which do I think is, so clearly there's some solutions that didn't work. There's a whole bunch of solutions that did work. And then it's looking at those solutions and saying, and which way do I think the user would best understand it of these 5 ways which did work? And then it will give you a result in the way it thinks that you would best understand that solution. And often you can kind of see the other examples it went through, but it'll come and show you these traces of how it went through some of its own thinking. And again, that's the third way in which some of this reinforcement learning has really improved these models. And so understanding that kind of training process, we realize how these models have been trained, but also it's important to know that, because when you've got tough problems, it's things like this extended thinking that you should make sure that you've got turned on. If you've got a simple question, what's the capital of France? You don't need extended thinking for that, right? Mm-hmm. But if you've got a really tough problem, you've got a really complex situation, turn on that extended thinking and it will go through that whole reinforcement learning process itself. I said I was going to pick up on hallucinations. And I said that the model, it sometimes get these things wrong. And in fact, I'm going to show you some examples of where I tried to trick the model into coming up with some answers which were wrong. Okay, so I'm going to turn to this one first of all here. So I asked Claude to list 5 notable people born on March 29th, 1847 with a one-line biography of each. I should be upfront with you, after thorough searching, it's clear no widely documented notable figures were born specifically on this date. The reason why I did this is because the models, although they hallucinate, they've been given a lot of strategies to help protect against these hallucinations. In this particular case, what's happened is, you see here, it searched the web. So the model has been given certain tools. And in this particular case, it went and searched the web, couldn't find anything on the web. And now it's come back and, it's saying, well, fabricating 5 names would be doing you a disservice. So I won't do that. So you can see here, it's picked up that potentially there's a hallucination here. I've gone to the web, I've validated it, and it's come back and said, no, I'm not going to hallucinate. Of course, I wasn't going to stop there. So in this particular case, what I did was I said, list 5 notable people born on March 29th, 1847 with a one-line biography of each. Do not use tools. Because I wanted you to understand this idea of using tools versus just relying purely on that vague memory of the internet. And you can see what's happened here is, here are 5 notable people born on March 29th, Elias Howe Jr. Wait, let me provide accurate entries. Ernst Haeckel's assistant era figures. Let me give you verified individuals. And it said, to be fully accurate without tools and avoid confabulating birthdays, here are 5 notable people widely recorded. And it starts listing them out. And then it comes back and says, like, oh, honestly, rather than presenting inaccurate birth dates, which will be a disservice, I should be transparent. I cannot confidently name 5 people I'm certain were born specifically on March 29th. So it started answering the question. And then I think it got into its extended thinking. And it said, hang on a minute, maybe I shouldn't be doing that. But you can see here, it actually did start to answer that from its vague knowledge of the internet, pattern recognition, and clearly it recognizes a pattern which I can follow about naming 5 people. The most likely tokens to come out are this Elias Howe Jr. and Ernst Haeckel's, and it started answering those questions from that pattern recognition. So you could see I could actually trick it, but eventually it did come back and said, hang on a minute, without the tools, that pattern recognition formula just really isn't right. I also mentioned about multiplication. So I took some numbers. I said, what is 53,416 times 2,556,993? Well, actually, the first one, okay. And I said to it, do not use tools. But in this particular case, it says, I'll work this out manually. So what it did was it broke it down. So it's using the extended thinking, the reinforcement learning pattern. And what it did was it then said, okay, well, I can work out this, I can work out this. And actually, it got the correct number, but it went through multiple iterations of its extended thinking. And it did, in fact, get it correct. So then I said, okay, now, what is 4,579,734 times whatever this number is? Do it in one step. It did it in one step. So then I said, okay, can you check it with tools? What it did was it used in this particular case, it used a script. It wrote a Python script. So it used code. The correct answer is 163,404,831. I was off by a bit. My one-step mental calculation gave me that, which differs from the correct result. Large mental arithmetic like this is very error-prone, so it's always worth verifying with the tool. Very important, if you're working with numbers, pattern recognition is not good enough. That's why and as you'll see, as we start building out our agent, we will build out our agent with a full suite of tools, especially tools to write its own code. Okay, do not be afraid of the code. It will do it perfectly well for you. And use these tools like code to do anything to do with numbers. So very important lesson to be learned there. Okay, so so how to mitigate these hallucinations? Always ground with context. If you give really good context, it's going to hallucinate a lot less. Use tools, web search, code, tell it to cite its sources. Use this extended thinking. We saw that with the arithmetic. And of course, the last step is make sure you verify any of those claims. So even though these models are really, really good, they can, going back to this idea, all it's doing is pattern matching. It doesn't actually know the words. It doesn't know calculations. It doesn't know any of that. The last thing I want to pick up on is the large language model as an operating system. And this is important because I just talked about how do we mitigate by giving it these various tools. And the way to think about it is think about it like an operating system. The model is really the CPU. It's the brain. Okay, it's got the pattern recognition that we just talked about. What you also do is you give it additional context. That's the context window. So that is if you put in some very specific information into its working memory, into its RAM, it's going to be much, much better. You're going to get much better results. You're going to get much more accurate results. And you're going to get something very, very specific. The other thing you do is think about it as having a hard disk. The RAM is what's in its current working memory. It also is able to load files in as needed. So as we start building out more context, start building out these contexts in a set of files. What we'll do is I'll ask all of you to go and download something called Obsidian, which is, if you go to obsidian.md, Obsidian is a way of writing text files in a way which there's a little bit of formatting associated with them, but really just think about it as text files. These text files are stored in a file format called .md, which is Markdown. And Markdown is really just a file which has a little bit of formatting associated with it. And large language models love to read Markdown files. They are very, very good at reading Markdown files because Markdown files are essentially just text files with that little bit of formatting, which makes them very easy for humans to read headings and underlines and italics and all that sort of stuff. Just a little bit of additional formatting, which helps us read it. But very importantly, the large language models love to read these Markdown files. And coming back to my operating system, these Markdown files are a way of accessing additional context, which we bring into our context window from the hard disk as and when we need it. The other thing is it's got an internet connection. It's got access to a browser. So you're going to see that one really good way of enhancing your agent is to give it access to a browser. So it can use the browser in the same way we do. It's got access to the web. Same way when we want to search things up in the web, it can access the web. It's got access to all of those tools the same way we have access to those type of tools. It's got vision. If you're stuck with something, the best way is to take a screenshot, drop the screenshot into the chatbot and say, this is what I see. It can read that because essentially what is an image? Well, an image is just a breakdown of pixels. Those pixels really are represented by numbers. Those numbers are exactly what the computer likes to read, and it can recombine that and does its pattern matching. It can understand an image equally well as you do. So having that vision is very important, and putting screenshots in is equally as easy as putting text into the large language model. Audio. One really easy way of working with the large language model is instead of having to type into the text box, you can just talk into the text box and it'll just do the transcription for you, and it will understand that transcription, and basically that's a nice easy way to work with the large language model. So it's got that capability as well. And then code generation. This is really important. Okay. And as we go through the course, we will be building our agent, and we'll be building it with code. And do not be afraid of the code, as I said before, because the large language model is incredibly good at coding. Even if you have never coded a line in your life, by the end of the course that we've done, you will be confidently getting your LLM to write code for you. If you want to, you can get it to explain it to you, which is the way I do it, because I always like to understand the code that is written, but you don't have to, because the code it writes these days is very, very good. And then there's the whole kind of system bus, which is the coordination, the way in which it manages all of these calls on the tools at the right time, pulls the information from disk and loads it into context window at the right time, and that coordination. And that is what we're going to pick up next week, is we're going to start taking this idea of the operating system, and we're going to talk about an agent and how does an agent get built with all of these components that I'm talking about here. And that's, I guess, probably one of the most important things, because it's going to give you a real grounding in, well, you can understand the conceptual idea here, but when we build the agent, I'm going to talk about all of these specific things here about how does it get these tools? How does it use these tools? How do we get the manage the context window? How do we load things into the context window? And how does an agent get constructed to be able to do all of these things? That is going to be the focus of next week. And hopefully you'll see that starting to come to life. I want all of you to go away and have a think about your digest. Start thinking about your weekly digest. Have a think about your week and what would you want to put into this digest, because as we build out our agent, this weekly digest is going to be the thing that we feed into our agent, and is going to be the thing that is going to be helping us in setting up our business or managing our work week or doing the things that we want our agent to do. So I'm going to send you a little bit of information on how you can get AI to help you build this. But fundamentally, I want you to be building the equivalent as what is your persona. Okay, so we had our Alex Okafor, who is his persona. Okay, I want you to start thinking about your own persona. And then I want you to start thinking about your weekly digest. What is going into your weekly digest? And we will start using these items to build out our agent. And eventually we will have something much more comprehensive than this. But this is really the starting point of what hopefully we'll start building over the next few weeks. Think about that.
I have a quick question. If the context window is very small and we've been using Claude a lot for various tasks, should we be deleting things that don't need to stay?
That's a very good question, Tiffany. And if I was telling you this 6 months ago, I would say yes. But the enhancements that they've made have actually really improved. Well, first of all, the context window's got much bigger. So a lot of the models have now got a 1 million context window size, which is very good. But also they've got strategies for dealing with this. And so what happens is, if, for example, you're using Claude Code, it's got this mechanism that as the context window fills up, when it gets to roughly 85%, it will invoke something called compaction. And so what it'll do is it'll look back the whole context window. It will then, in the background, invoke a model to summarize everything that's happened. It'll summarize everything that you've done. It will then delete the context window and just load the summarized file into the context window, which then frees up a whole bunch of context. And essentially it can just keep doing that and keep doing that and keep doing that. Eventually, I think it is better to not use compact too many times. You can compact yourself. So let's say you reached a natural breaking point and you think, okay, I want to move on to the next thing. You can compact yourself even if you haven't got up to the 85%. But normally what I do is I reach a natural breaking point and I actually then just cut it off and start a new fresh session. And the reason why I do that is because my agent has already got all of the background context, which it loads every single time. So when I start a clean session, it's loading my profile, it's loading all the stuff that I wanted to into my context window with just enough information that I don't start with a clean slate. It starts with a good context about who I am.
Gavin, just so to sort of manage expectations, I notice you're using Claude Code, so Claude Console there. Will you be running through the different ways in which you can access Claude Code? Because obviously you can operate in the terminal, which I know is what you're doing most of the time, I think. But we'll be covering, because some of that, what I call the architectural stuff, I find is the more difficult bit once we start getting practical to actually get your head around.
Yes. So I'll be covering Claude.ai, which is basically the chatbot version. I'll be covering Claude Desktop, which is the desktop app where you can kind of operate in multiple different modes. And I'll be covering Claude Code, which is can be operated either in the terminal or in VS Code if you prefer. So I'll cover all of those different modes of operating.
Super.
And whichever one you feel comfortable with. As you say, I use the terminal. If I just show you for a moment, so I start Claude in the terminal like this. I go Claude, and that's then opened, and I can ask it what was my week like. Let's see what he comes back with. What it's doing is it's going into all the stuff that we worked on over the course of the week. It's analyzing all of that. It already had loaded into its context window who I am. Let me just also open Claude Desktop. You can just do normal chat like it is here. You can use Claude Cowork, which is here, or I can use Claude Code in the desktop. So that's the desktop app. And then, of course, you can just use Claude as normal in just .ai, and the normal kind of chat can happen in Claude.ai. So those are the typical ways of using it. Okay, there we go. Week of 18/24, productive, MedTech version 2 is the backbone. There we go, Liesl. Skill architecture cleanup, MedTech 2 rebuild, AI training session, obviously second brain consolidation. I was working on some skills. We worked on the Google authentication. MedTech version 2 is the biggest ship thing this week, which is correct because Liesl and I were working on our new venture together, and I was building the website for MedTech. So that kind of shows you I just opened a fresh session, but of course it knows who I am, it knows what I'm working on, and it's able to do all of that.
Can I take it that all the slides were created in AI by your agent?
They were actually the slides.
Cool.
I thought they were pretty good. So in this particular case, I used the new ChatGPT Image 2 model.
Oh, right. Okay.
Here you can see exactly how. Okay, I'm building a training course, and I've attached the first version of the outline notes, and you generate some images. Okay, it came up with this horribly generic. So of course I said, okay, the image generator is completely generic, rather than based on my specific notes. Can you review the notes again and generate an image for each subsection with the module? And it then came up with something much better. Okay, always okay. But then I said, okay, much better. I want individual images. And then I just went back and forth, and I kind of tweaked the various things based on various aspects. But of course, what I had a very detailed set of notes, which I generated for this course. And of course, as we just spoke about, that specific context, because it was so specific, those slides really didn't need that much tweaking. I mean, if you look at this, that's it. That's all the tweaking that I did. And that's because the session notes were incredibly detailed. And so what it put on those images were spot on what I had in my detailed notes. So if I come here for a moment, if you look here, here is my notes. This is Obsidian. So I had right the way from the purpose, prerequisites, my instructor prep, the agenda, topic by topic, opening hook, section 1.1, 1.2. I had all the detail on here, and essentially all of that context allowed it to generate a very, very good set of images. I always say, like, spend your time getting the instructions right. Don't spend your time actually working on the AI itself. Spend your time getting the context right. once you've got the context right, the AI is going to give you a great answer.
Yeah,
It really
yeah.
is. 9 times out of 10, it's going to give you a fantastic answer if you've spent the right amount of upfront time on the context.